Welcome to the Formulation Station, a series of video tutorials demonstrating what can be done with Food Solver. Food Solver is a revolutionary new food development tool which brings the advances in software, such as artificial intelligence, to your food development. If you would like to know more about Food Solver, please visit www.foodsolver.ai, where you can also sign up to join the beta test. Now, our first request comes from Sam in New Zealand, who asks, can Food Solver be used to calculate my product's carbon footprint? P.S. Love the show. Well, thanks, Sam. I really appreciate your preemptive positive feedback. And to answer your question, yes, Food Solver can be used to calculate your product's carbon footprint. Not only that, you can actually use the model within the solver to purposely develop new formulations or to reformulate your products to minimize the carbon footprint and still achieve the other attributes you require. And I am going to show you how. I will be splitting this into three sections. The first, I will show you how to set up this calculation in your formulation. The second, I'll just be talking about where the data is coming from and how it's being calculated. And then the third, and most importantly, how we can use the outputs in the solver to formulate new products purposely to minimize their carbon footprints. Alright, so how do we set this up in a formulation? You'll see here I'm on a project screen. I have a couple of projects here, nothing major though. What I'm going to do is use a cereal bar example here. So let's go into the cereal bar project. Once we're in here, you see I've only really got one formulation group I'm working on. If we open that, you can see we'll go into version 1 of my typical cereal bar. Right, what we have here is a very nondescript cereal bar formulation. You can see very general ingredient descriptions there. I've split the formulation into two groups, the top group being the binding syrup, and then the bottom group here is the dry blend. As you can see, our binding syrup has some standard ingredients there, lots of sugars, syrups, a little bit of oil. We've got some apple juice for fruit claims, and then a few other things there, some fiber, and then we've got our humectants. And if we go to our dry mix, you can see we've got some rice bubbles for a nice crispy texture and the right density, and then toasted oats for a whole grain claim, and some dried apricots for a fruit claim. We're also fortifying some protein there. If we go over to the right here, you can see we've got your typical compositional breakdown along with a cost analysis there. If you go to the composition here, just some typical nutrients plus a few extra things that we are sort of claiming. You see the added sugars, and then we've got some fruit down the bottom. So now we want to get the carbon footprint into this. We're going to use a calculation for this. So we go to our calculation tab, and then you can see we've got a few calculations open, nothing major. We're going to search for the carbon footprint calculation. And so you can see here it's come up there. Just click on that to load that into the system. You can see it's calculating for us, and if we go back to our compositional tab now, or the compositional side of the screen, you can see our calculations loaded, and down there we now have our carbon dioxide equivalent. This is in kilograms of carbon dioxide per 100 grams of our product. And if we hover over the data value, it pops up now where that carbon dioxide is coming from in each of our ingredients. So this is the breakdown of the CO2 equivalents of each of those ingredients and their contribution to our product. Okay, so where's this data coming from, you might be asking? Well, it's actually coming from one of two sources. The first, which I'll discuss quickly, is the most simple. It's simply added by the user to each particular material in the right area for that data, which we'll show you now. If we head into the project materials, it will bring up all the materials within the project. We'll go into a material that has this data loaded into it, such as the glycerol over here. If we click on the little pencil button, it will bring up the edit window, letting us view the components within this material. As you can see down in the supplementary information, which holds lots of non-component based information, there's an area for footprints and a carbon dioxide equivalent value. This is in kilograms of carbon dioxide per 100 grams, and see it's been entered in. And you can also see the composition of the material down in the composition area. So you're probably thinking right now, what about all these materials that we don't know this information for? That's where the calculation function within the system comes in real handy. We can create a predictive model that will use data sets based on, say, categories of ingredients to predict the carbon dioxide equivalence of our specific ingredients. So I'll show you this now. We created a model here which can assess whether a material's got the data within it, and if it doesn't, it will know that and then use this predictive model to generate that data. So it's not overriding any user entered data, it's predicting data for what's not there. If we go into our calculation and click Edit Calculation, you can see here a large data set by category. So this is assigning a category a different carbon dioxide equivalence, and then it will note the category that the material is, or multiple categories if it is, and then assign this carbon dioxide equivalence to that category. Now it's a little bit more complex than this, which I'll go into in a bit of detail, but your first question is, where's this info coming from? And I basically just found a research report that's been publicized. This was by Oxford University, and it just has found the carbon equivalence over many different categories of many food categories, as you can see down here. So it's a perfect data set for us to use in such a model like this. As more data comes out, these models within the system can be refined based on that data, but this is a great example for us to use right now. So that data has been transferred into our model here, and then we've put reference quantities for the total solids of each of those particular categories. So that number was based on 1 kg of that particular food. All of those have various solids contents. So what we need to do is calculate that on a dry basis and then recalculate that back up to our material based on its solids content. Once that's been done, it's assigned to the material just like the user data, and then it's used to calculate the formulation's carbon equivalence. Okay, so this is the final section and where we'll spend the most time actually formulating using these models. We're going to use the solver function for this and set some targets. So as you can see here in the target set area, a few have already been set, one for protein, one for fat there, and especially if we go down to our carbon equivalence, carbon dioxide equivalence, you can see it's been set to 0. Now, this is a big ask, so let's have a look. It's been set to 0, but we set the priority to low because we know it's unachievable to really hit 0. So if we set a lower priority, it gives the system a bit of information there that the other requirements are higher priority, and it's more likely it's going to hit those instead of do everything it can to bring that to 0. If we really wanted that to be 0, we could set that higher, but we're going to miss a lot of our other targets. So let's have a look at our other targets quickly. Our product has a protein claim or a protein requirement, so we've set that there. It's also got a fat limit that we need. That helps with processing, so that's been set to match. Set our protein a little bit higher to meet the claim. Let's see how the system goes with that. It always likes a good challenge. Now we're looking here at the sugars in the system. We can't really just set sugar. It doesn't really give us the whole picture because we have such a mixture. We've got milk that gives us lactose, fruit that gives us the fructose. There's glucose syrup in here, so you would expect that there'd be glucose. And there is the wonderful good old-fashioned sucrose. So we basically got a cocktail there of 4 different sugars, all contributing to our product's sensory. So it's going to be hard for us to control that just using sugar or just restricting those as well. So instead of trying lots of different variations of that, what we can do is use one of the pre-made calculations here. This one is on sweetness, which calculates the product's overall sweetness based on the sugar and other sweetening compounds makeup. As you can see down here, there's a fair bit of information on the sweetness. We'll just use the sweetness intensity for now for simplicity's purposes. So let's set to be roughly the same. And then we don't have to worry about any of the other sugars or carbohydrates or the sugar alcohols that are in the system. They'll all be taken care of by this. So we're getting closer now. We've only set a few targets, but it's looking like the AI will have a fair bit to work with. But we don't want to stop it just filling the system with water. So what we can do is actually control the product's water activity. And again, we'll use a calculation for that. So we've got a predictive model based on some literature. We'll use that in here, and it gives us a good idea of the water activity, or at least what it thinks it is, to give us a good way of keeping things standard. So we go down here, you can see water activity has been loaded now, and we'll just set that to be the same or roughly the same. Now it's good to remember that these models are predictive ones. As more data becomes available, these can be refined to be much more accurate. So in this case, it doesn't matter too much if our water activity goes too low. So we're just going to set a range instead of just one target to give it a bit more room to work with. We'll keep the priority level the same. When that's done, we'll have another check through to see if we've got all our targets set that we think we need. Looking at the composition here, we've set our claim on protein, we've set our fat. If we look down here, we've actually got a whole grain, but we'll fix that. I'll show that later. And we've got fruit. We want to make sure it doesn't reduce our fruit because we've got that labeled on our product packaging. So let's keep that the same and set a target for that one. Or reduce it by about half. Better. All right, so now it looks like our compositions are set. We've got things controlling our sweetness, our solids content, and the makeup of our product, and then our key claims. And we've also got the whole carbon equivalence. Now what I'm going to do here is go to our formulation, and you can see there's a little lock symbol next to each ingredient. This will make it so that the solver does not use this. So the AI knows to not change this ingredient at all. So whatever's there will stay there. So we're going to lock our rice bubbles and our toasted oats because that's the makeup of our dry mix. It gives the product its texture and basically its overall body. We'll also lock the fruit content because we want that there, and we know that that's a good amount to give an apricot-y type taste in this product. And then we'll just click this little balance button here. This helps the system to know that we want every ingredient to sum to the same amount still, and it just gives one token ingredient to keep changing to hit that amount. When we're solving, it doesn't really matter too much because everything's going to change, but it's nice to just have that set so that we always get the same total of 100 when we do this. So looking through, have we locked everything we want? We'll leave the 2 protein sources to change because we don't really have any claims around that. Have a look here, actually, we've got gelatin in our syrup. This is there to help with aeration and for sort of a chewy texture. And we're going to want to keep that still. So what we can do is lock this one in place as well. And then the AI will know to keep that there too. So we'll put that lock on. Now everything's there in place. What we can do is actually start the solver running now. So we just click the start the solver button here. And you'll see a new column has appeared now in our composition area and our formulation area. And the one on the left is the original, and you can see that one's called solved. So that will appear, and that's the new formulation that the system has developed for us. As you can see here, it's showing us one that it's made. So we have a direct comparison between what was and what has been calculated by our friendly AI. So the good thing to do is check our composition, see what it's done. Has it found something? So right now we can see that our protein not quite meeting what we've set. So that's probably because we've told it to do 0 carbon dioxide. Our fat is slightly under 2, and there's no surprise either with the 0 carbon dioxide. We can resolve those though. So what we can do with the protein, if we open this and just change our priority level, bring that higher so it knows it's more important. Almost instantly, it brings our protein back up to what we want. Great. And then one thing I've noticed is that we do have a fiber claim on this product, but we haven't told it. So you can see it's reduced the fiber quite considerably there. So we're going to just open this up now. It doesn't matter that the solver is still running. And we'll set a target for this. And there we go. It's brought the fiber back up for us, which is great. So we're getting closer to the product that we want. And we can check a few other things now. If we move around this composition area to see if everything's sort of meeting what we expect. So our fruit seems okay. Our carbon emissions have reduced, not massively, but I don't know if there's that much we can do. So let's see how it's got this carbon reduction for us. Really, the only thing it's really shifted is it's seen our protein sources and taken the animal source of the milk powder and replaced that with the plant source from the soy. The other sugars from the milk powder, it must have sorted out with its sweetness model to just contribute different sugars from the other area. And that's resulted in a slight reduction in the carbon equivalence within this product. We'll have to make this and see how the taste compares to the original one with that extra soy protein. But that's what this is for, being able to evaluate lots of different formulations. Right, what I'm going to actually do here is add a new material for it to work with. So as we saw in the data for the keen-eyed, palm oil came in with quite a high carbon footprint. So we can try and give a different fat source to the product to use, or to the AI to use really, to see if that can bring it down, because some of the other fats from different sources may have a lower footprint. So I've added the coconut fat here, a hydrogenated one, so it should have quite a similar function to the palm oil. And we'll leave that at 0 because we don't need to change it. We'll just let the AI deal with that, and then we'll just start it again and see what happens. And as you can see, almost instantly, all the palm oil has been removed now, and it's all been replaced with that coconut oil. And not much else has changed here because the other things are still meeting our requirements, and we're basically replacing a pure fat with a pure fat. But we check our CO2 equivalence. That's come down far more considerably now, which is a great result for us. So now we've got another potential formulation to work with that we can compare with our original to see what happens. Let's just check some of the other stuff. Sweetness is still meeting the requirements. Water activity is meeting our range that we set for it. So I'm starting to feel good about this one. Everything's sort of in place. So what we can do is we can click the Accept Changes button at the top, which will stop the solver and overwrite this original formulation with a new one. And the 2 columns disappear back to 1 again. And now that we're feeling good about this, we can actually make a copy. And this is where we have the great opportunity to make a good pun. So definitely we will do that. And then we will save this. So now we've saved our formulation. All right, we're almost done. Although some people may have seen that we have a relatively large amount of sorbitol here at 19%, nearly 20. Let's control this because we don't want this to be this high. So we can control this by controlling the polyol group. So sorbitol fills under this, so does the glycerol. Let's load that up, see what's actually in our product. Let's also just load up sorbitol, see what we actually have as well. All right. So if we hover over these, you can see we've got a fair amount. See, sorbitol is actually coming from 2 sources, the apple juice and the sorbitol. But the apple juice isn't contributing too much. So what we can do, just load up this targets again. Let's set a range. We don't really want it to go too low, and we don't want it to go too high. We want the water activity and the product texture, but we don't want any of the negative side effects. So let's set that one up, and let's start our solver and see what we get. When we wait, here we go. So the sorbitol is reduced, and the glycerol's been eliminated. So it's brought the polyol down to that level now, using what it thinks is best. So it's achieving sweetness with sorbitol. Glycerol's not quite so sweet. But let's give it a bit of extra control because we want the sorbitol to actually be a bit lower than that. So let's restrict just the sorbitol. And as you can see there, everything's adjusted again. Now the sorbitol has been reduced, the glycerol has been increased as we've set separate targets for our polyol group and our sorbitol group. Check everything else. Seems okay. We can accept the changes and save. I'll just give this an extra name. Alright, so now we have two formulations which we can try. One with reduced humectant. Okay, and that's the end of this demonstration. Thank you.